Welcome back to the Foundation C# course. We're currently in Module 8, and this lesson we're going to be covering MongoDB, which is one of the more popular NoSQL databases. Okay, so let's go to our Visual Studio, create a new project. We're going to create a brand new project this time, console app, and we're going to console.net core version of it. We're going to call this the MongoDB UI. Okay, and the solution name we're going to call NoSQL DB solution. So you had the relational DB solution. Now this is a NoSQL DB solution. And we're going to do something similar where we put both Mongo and Cosmos DB in here so we can see the differences. Now let's start by getting rid of this. We'll put our console read line at the end. Right before it, we'll do our done processing MongoDB, just so we have that in there. I'm also going to paste in that code from the other project that is our configuration builder. Add a reference to our NuGet package, which is microsoft.extensions.configuration.json. We'll install that. This is kind of setup work for our project. So control dot to add the using, control dot again to add the using. Let's go. It's not. There we go. Nope. Someone's kind of clogged up with my system. So using system.io. That should solve that problem. That's a Visual Studio bug of some kind. I'm not sure what. And now let's add a new item, and we're going to add an app settings.json, which that's a config file, just so you know, application configuration file. That's not what you want. Create a class library that actually talks to MongoDB. So let's search for a class library, .NET Core. So there's let's choose C#, and let's look for a .NET Core version of the class library. And we'll call this class library Data Access Library. We'll use it for both, and delete class 1. We'll use it for both MongoDB and Cosmos DB. Okay, so let's add, in kind of a similar fashion to before, we'll add a MongoDB data access. We'll make it public. And this is where we'll do our generic work to talk to MongoDB. Now to do that, we have to add dependency. So NuGet package, we're going to look for MongoDB, and there's MongoDB.driver, the official .NET driver for MongoDB. That's the one we want. We're currently on 2.9.3. All right, so once it installs that, we'll be all set to talk to Mongo. Now, just like with SQL, I'm going to build out this generic data access class, which really you can copy and paste this class just like the others and use it over and over and over again without having to retype this or rebuild this. So I'm actually going to put a couple more values in here or options than we'll use. But I'm going to talk through what I'm doing. So let's start with a constructor. And this constructor is going to take in a couple of things. String DB name and string connection string. All right. And let's go ahead and what we're going to do is let's create up here a private MongoDB client. All right, so private MongoDB, or actually Mongo database. Control dot to add the using statement for that. So Mongo database, we'll call it DB. And then down here we can say var client equals new Mongo client. And we need to pass in that connection string. Now, like I said, you don't have to have this connection string. If we do a Control Shift space, well, it's going to go off the screen. But there's multiple options here for what we can do, and one of them is nothing. Okay, we don't have to have any parameters here. We can leave that empty. Now, if we want, that's going to just connect to the local machine and assume that's what it is with no password. Whoops. Let's undo that. Let's put our connection string there just so we have it, though, in case you want to connect to a different machine or add a username and password later. Those are all options in your connection string. And now we're going to say db equals client.getDatabase db name. And that's going to connect us to one specific database on the MongoDB server we've specified. So on our local machine, we're going to choose one database and connect to it, which is similar to what we do with our connection string in SQL, MySQL, or SQLite, where we said not only where is the server located, of type T from a table name. Okay, so get the collection, get the whole table, and then collection dot insert one, and this is record. Okay, so we're going to insert one record into the collection. All right, so that's all we do for an insert. Now, you may be wondering, where's the SQL statement? Where do you say insert into these columns? We don't do that. We just say, here's an object, put it in. That's it. Okay? Let's do a read and see how this works. We got the create, that's the C in CRUD. Now we're going to go for read. We'll have two different types of reads. First one is read everything. Public list of type T, load records of type T. Let's give it a table name. Okay, we're going to say this table, load them all. So var collection equals db.getCollection of type T, and here's the table name. Look kind of familiar? That's the same thing we did up here to establish the connection to the table. We're going to establish the connection to the table, and then we're going to return collection.find. New BSON document. Let's try this again. bson document. There we go. I believe it's control dot to add using mongodb.bson. Remember I said that it's not quite JSON, it's bson, but for our purposes, for how we see it, it's JSON. Okay, so bson is technically the style because it's binary instead of that JavaScript object notation. So it's a little bit different, but it's just basically a compression. So we're going to say, you know what? Kind of like our new empty constructor for what the parameters are for our relational database, we're saying find where it matches basically anything. Give us all the records, and then return that to list. So when we ask for a collection from this table, we're going to map it to type T, kind of like what Dapper does, but there's no Dapper here. And then it's going to return a list of type T out. So these two lines right here open up a table, map everything to type T, and then return it. Okay? That's a read everything. Now let's do a public T load record by ID. So it's going to load one record by its ID. Table, and then GUID ID. Okay, it's a little bit different than a string, but you could think of it as a string. But a GUID is our unique identifier that we use in NoSQL. It's not the auto-incrementing integer. It's a string that is unique. Okay? So load by ID. So we're going to start by doing the same call yet again to get the collection and say var filter equals builders of type T filter EQ. The ID column needs to match ID. All right? So what we're doing is a little bit of advanced work, and we're going to get into a little more about link and about lambdas soon. But what this is doing is creating a little filter. And the filter says, based upon the type you're using, okay, we're going to filter it where equals, meaning not greater than, not less than 2, equals. So the property name of ID has to match this value, which we passed in. That's the filter. It's kind of like the where clause in a relational database. Now we will return collection.find, but instead of passing a new bson document, it will update the record. If it does not, it will insert the record. So an upsert. You'll find this in relational databases as well. So string table, GUID, not guild, GUID ID and T record. So this is going to do something similar to the insert record, only this will fail if the record already exists. So this way, we're going to upsert it, meaning if it doesn't already exist, we'll insert it. But if it does exist, we'll just update it. So we're going to start with our same var collection. We're going to get that, establish a connection. And we're going to say var result equals collection dot replace 1, and let's wrap this line because we're gonna need to wrap it, I think. So let's start here and say new bson document where the underscore ID matches ID. And here's our record to pass in, and new update options to say is upsert equals true. Okay. Now I think we're missing our close paren. There we go. So what this is going to do is it's going to create first of all, a connection to our table. Then it's going to say, let's replace one record. And the record we're going to replace, the underscore ID, which is it's a private value. It's a standard value that all MongoDB uses as a unique identifier for every single document. So we're going to say the document that has the ID, underscore ID of this value, which is the GUID passed in. I want you to replace that with this record right here. But one of the options is for the update is it's an upsert. Upsert equals true, which means that if you don't find this match, don't just stop. Because you can't replace it, obviously, if it's not there. But don't just stop. Instead, insert that record into the collection. Okay? That's what an upsert is. Now, I find I use that quite a bit. And the final one we're going to have, which we probably won't use, or at least not based upon our current requirements, is public void delete record of type T. String table GUID ID. Now again, we're going to take our collection, start there. We always talk to our collection first, or establish a connection to that collection. We're going to set up a filter, and that filter is going to be just like here. Okay, we're going to grab the filter based upon the ID, going to match that up, and then we're going to say collection.delete 1 and pass in the filter. All right, so it's going to delete the first one that matches this record. Since the ID is unique, it will only ever delete the one. If you did delete many and you matched it on last name equals Corey, then it would delete every Corey in the database. But in this case, we're just going to delete one record that matches the ID. Okay, so that's our delete statement. Now, I said we're not going to use that very often, and I will show you why in just a little bit. But essentially, we're not going to have multiple tables like we did in SQL. We're going to have one table or one collection, and that'll be the contacts collection. But in order to have that, we need to actually have a database. So what we need to do is we need to go to MongoDB first. So if you go to mongodb.com, you can install MongoDB. There is a community edition for free. So community server is free, and also you're going to want Compass. Compass is the GUI for MongoDB. Install those two things. I'm going to pull up my version of Compass here. There we go. I have connected to my cluster, and now I have these 4 databases normally. Well, I have them because I've been messing around. But now let's create a database. We're going to call this database the Mongo Contacts DB. Okay? And the collection name is going to be Contacts. And we'll hit Create Database. Okay, so now we have Mongo Contacts DB. And inside there we have one collection, which a collection is like a table. And that collection is Contacts, which has no records in it right now. All right, but that's it. We've created our database. We've created our okay? Because we didn't call it underscore lowercase id, okay? So we're saying we want to map this to your unique identifier for this document. Now we're going to say string first name. I'm going to change that N to be correct. And also string last name. Okay, so there's our first and last name. We still need our email address model, which honestly, we're just capturing, right now, we're just capturing email address. But I'm still going to create a class for it. Because if later we want to add what type of email address, it'll make it easier. Okay, so prop string email address. No ID, just that. Okay, we're going to create another model for our phone numbers. Phone number model. Again, because we want to allow for the additional properties later on. But for now, phone number is all we have. And now in here, we're going to say prop list of email address model, email addresses. We're going to say equals new email address model. And list of phone number model, phone numbers equals new list of phone number. And that's it. We don't have any of those linking things or IDs for our other models. That's all we need. Okay? We're going to save this entire document, including this list of submodels, in one table. Okay? In one document. So let's do that. Let's minimize this, and we're going to create a private. Before we do this, let's create a connection to our database, and we're going to bring it out here. Okay, so we're going to say, we called this the MongoDB data access. Control dot to add the reference to our class library. Let's just call it db equals new. We have to pass in a connection string name and a db name. I can use this everywhere. We've established it and create it once. So now we can say private static void create user or create contact. And I'm debating if we should pass it in. I think we should pass it in. So contact model, control dot to add that using statement, contact. Now we can say db dot, let's do our upsert, because that way we're safe. We're going to pass it into a table name. Let's create a private static read-only string. And this is going to be table name equals and the table name is contacts. Okay, so we're going to pass in the table name, our GUID ID, and the record. Well, we're going to pass in contact.id as the GUID ID and contact as the record. Okay, now the reason we're passing in the GUID, even though it's already in the contact object, is because in our upsert, let's go back and look at our upsert. We're looking for this ID value, but record is of type T. We don't know if it has an ID value. So therefore we pass it in separately so we can have that value and then just insert or update that record. So we're passing it and just doing an upsert. And guess what? That's all we have to do to either insert, create our contact, or to update our contact. So let's call this method the create contact. So we're going to create a model first. So contact model, let's call this user equals new contact model. And let's put our ID in here, which let's default this because I don't want to create a new GUID each time. So in our contact model under GUID, I'm going to say equals GUID.new GUID. All right, that's going to create a new GUID by default. And a GUID is a unique text identifier. So now I can say first name equals Tim and last name equals Corey. And now I can say user.email addresses add tim@imtimcorey.com. And I'm going to do it again, but this time I'm going to add, oops, I can't do that because it's a new email address model with an email address of tim@imtimcorey.com. Like so. They create a whole object out of it, which does make it a little bit more of a pain, but it is more flexible. And normally you're not building these by hand on the command line or on in your program.cs. So now I can say user.phonenumbers.add new phone number. Again, it's a model, so phone number equals 555-1212. And we'll copy that and paste it one more time. This time 555-1234. So there's our model like we had in our relational databases, or very similar. Now we can say create contact and pass in user. And that should be it. Let's run this. See if it runs the first time. And it says, nope, can't find the app setting.json. Guess what we forgot to do? Okay, I forgot to do. Every time it seems like. I got it right once. Let's try this again. Done processing MongoDB. So let's go to our MongoDB contacts, and we're going to do a refresh here. And now we have our first record. Let's see if we can zoom in here on this record. So we have first name is Tim, last name is Corey, email address is an array of objects. There's my two objects, and phone number, same thing. So now we have a record for Tim Corey. That wasn't that hard, right? I just said, here's my object. So I create my object, and then I just said, go ahead and stick that in. That's all there was to it. Let's comment out the create contact, and we'll do another. We're going to do a read next. Actually, let's create charity first. So creating this record just means go ahead and create that. We'll launch it. It'll create. It'll be done in half a second. And now we have 2 records in MongoDB. So you refresh this. Now there's 2 records, one for Charity, one for myself. But we have duplicate data. And that's going to have to be okay. You're going to have a primary source for data of certain types. Okay? Where you say this is the authoritative data. And if you find duplicates somewhere, which you will, then just know that if it changes somewhere, the authoritative version is the one to look at if you're not sure. Okay? So it does add a little bit more work on that side, but you saw how easy it was to insert a record. Now how easy is it to read all of those records? Let's find out. Whoops, not there. Private, static, void, read all, or get all contacts. Get them all, okay? And not void, it's going to be actually a list. No, let's do void and let's just print them out. So let's say var contacts equals db.load records. And the records we're going to load are, we've got to give a type T. So a type T is going to be contact model. So getting a list of contact models from, and our table name is going to be table name. That's it. Okay. So now I can do a for each. For each contact in contacts. And let's print out the the first name. So contact.firstname space the contact.last name. And before we do the ID, let's do the same thing. So we're going to say contact.id, and we'll do that colon afterwards. So that's the record. We will pause it right here to make sure we have all the values, the phone numbers and whatnot. Just going to pause here. Hopefully, it's not because we're not actually calling it. Okay, we've got to actually make a call to get all contacts. And now we will run this. Okay, we had to make multiple calls to get all those things attached. Not with MongoDB. It's a whole document. You get everything. So now you can see that if we run this, there's my GUID, there's Charity's GUID, and there's our information. Okay? Now let's run that one more time real quick. So we get a GUID. I'm going to get this GUID right here, which it's a little harder to get than, say, a number, because auto-incrementing numbers are great, especially when you're starting out, because it's really easy to remember 1 and 2. A little harder to remember the IDs. Now I'm going to paste this up here just so I have it. There's that GUID. Okay? I am going to do a lookup on that GUID. All right, so let's create a lookup by ID. Private static void get contact by ID. We can pass in a string for our GUID, or we can pass in a full GUID. I'm going to pass in a string. And the reason why it seems like that'd be simpler because I'm going to probably be copying it from somewhere rather than getting it as a GUID. I'd probably overload this to also take a GUID, but strings seem like it'll work just fine. So we have the DB and load record by ID, which first of all takes in a type T, which is our contact model. And it's going to take in a table name, which is table name. That's our read-only string. We have a GUID. So instead of passing a GUID, I'm going to pass a string in there. That's not going to work. So let's just say our GUID, let's call it GUID, equals new GUID passing in that ID, and that's going to convert it to a GUID, which there we go. Okay? And we can return, actually no, we're going to capture that, contact equals, like so. And then we can run just this line right here just to prove we got it. Like so. And now all we need to do is we need to call this. So we can say get contact by ID passing in that string, which will be a GUID, which will convert to a GUID. Let's try that out. There we go. There is Charity Corey because we looked up her by her GUID. Now let's go get my GUID because we're going to change my name. Okay, so we're going to do an update here. So we have this right here. That's my GUID. And I'm going to save that. So I'm going to put this right here. There's mine. And now what we're going to do is we're going to create an update. Private static void update contact db.upsert record and pass in the table name, pass in the GUID, which is contact.id, and pass in contact with the updated record. All right, so let's do that, and then up here, we'll say update contact first name to be Timothy, and the GUID is, we'll pass that in, which that is this right here. And then once we've done that, let's get all contacts so we can see that in fact it did update that value. So we'll run that. And now we see Timothy Corey and Charity Corey. So it has updated my record to be Timothy instead of Tim. So that's our update. Now this last one, we're going to probably do a little bit of, I don't like to call it kludge, but kind of, which is public static void. We're going to remove phone number from user. Okay? So I'm going to pass in the phone number to remove. String phone number and also the ID of the user. Okay? This is going to look very, very similar to this to start off with. We're going to get that contact based upon the ID. Then we're going to say that we're going to remove just the phone number that matches. One way to do that is to say contact.phonenumbers equals contact.phone numbers where control dot to add using system.link. I'm going to go over lambdas and link in a future video in this series, but I'm going to show you a little bit right now. The where allows us to do this syntax. X dot phone number is not equal to phone number. Okay? To list. What this is going to do is going to run a little bit of a query on our data. So we have a list of phone numbers in our contact.phone numbers. And we're going to say, give me every phone number, that's the where clause, where the phone number does not match this value. So it's giving a list of every phone number that does not match that value, and it's going to return it to list. Okay? Again, we'll cover more in depth what's happening here. This is just a little filter. Now I have updated the contact phone numbers. I'm going to say db.upsertRecord and pass in the table name, the contact.id, and the contact. That's it. Okay? There's no calling the delete because we're not actually removing a whole document, just parts of the document. So let's do this. We have updated Tim. Let's go ahead and remove phone number from user, and we're going to remove the 555-1212 from Tim. Now this is a string match, so it has to match exactly. Not ideal. There's better ways of doing that eventually, but this I think is just fine for our demo purposes. In real life, what we probably do is we would remove it by first finding a list of all the phone numbers associated with me in a drop-down, and then get that phone number to have it match exactly. But we're going to remove the phone number from the user. Okay? Now let's go over to our MongoDB Compass, and we're going to refresh the data and see Tim is now Timothy. And phone numbers, let's zoom in here. Phone numbers, we have two. We have 555-1212 and 555-1234. Charity has two, 555-1212 and 555-9876. So we both have that 555-1212. Let's go ahead and run this code, which will remove it from my record in theory. Okay, and it says done processing MongoDB. Let's go back to our compass, and let's hit the refresh button. And let's look at my phone numbers, which I have just one now, 555-1234. My wife still has two, one of which is 555-1212. So it only removed the one that was associated with me because that's the only document we worked on. Okay, so there now is our full CRUD operation. That we're going to say db.deleteRecord, and we have to pass in the type T, so it's contact model. The table is table name, and the GUID is GUID. That's it. So now we can say remove user and pass in just the ID, which is this GUID right here. That's mine. I hope. Let's find out. Gonna run that. Done processing. If we go back to our compass, we refresh. Now there's just Charity there is no Tim record because Tim is gone entirely. Okay, that's how you delete a full document. But normally, what you end up with instead is you're removing parts of a document, not the whole document. Okay, so that's all there really is to MongoDB. This code right here, that code's going to get you everything you need for about 95% of the scenarios for reading and writing to MongoDB. Notice we never even called insert. I have it there. You could use it as long as you know that it's only going to insert records. It's not going to update them if they already exist. Okay? Otherwise, that's all we need for Mongo. Hopefully that's kind of makes sense. It's going to take a little bit, like I said, just like with SQL. You have to do it a couple times, try it out before you really grasp it. So let's go to today's pro tip, which is just because you can doesn't mean you should. Don't be sloppy with your data designs. Now that you've seen NoSQL, it may feel like, man, there's no way I'm going to SQL and that relational database with all the different tables and linking them and all the confusion. I'm just going to create this massive model and shove it into Mongo because everything is good. It's not quite that simple. Okay? There's a speed issue there. You're going to have to make sure that you design your model in a way that makes sense, in a way that you're not pulling back gigabytes worth of information when you get into a production situation. You need to design things a little more carefully than that. So on the surface, MongoDB looks very, very easy to use, and it really is in a lot of ways. And it really still is fast. But there are some downsides too. Relational databases can be very fast. They can be better at working with that data integrity. You saw that it was basically duplicate data for our phone numbers. Well, that might not always be a good thing. You got to be very careful how you deal with that data and don't just get sloppy. You have to make sure that if you're updating a phone number, that you update it everywhere if it's stored in multiple places. But it's also a lot of upsides to Mongo as well. So just know that it's an option and that's a good possibility. It can do pretty much everything SQL can as far as performance-wise, scalability, and even the ACID test, which is a test for databases to make sure that they're, I'm not going to go through all of ACID, but essentially it's to make sure your database or data is safe in how it's written, so that you're not going to half write data and cause problems with consistency. Mongo can be ACID compliant, but just don't get sloppy with your design just because you can. Okay? A lot less controls around Mongo, but that does mean you getting a little more careful about controlling yourself. Okay, the homework. Build a simple database in MongoDB that holds people, addresses, and employers. Make sure it builds and you can load and save the data in C#. Once you've practiced a little bit with Mongo, you're going to find that this is a whole lot easier lesson to do the homework for than the SQL version. The SQL version, you probably struggle a little bit. And hopefully by the time you hit MySQL, you were getting a little better at creating that structure. Don't bring the same structure over. Make sure you target the structure for the database you're using. So MongoDB doesn't have to have all those IDs all the way down, and they're also not auto-incrementing IDs. Make sure you design your models and your structure based upon what type of database you're using. But give us a shot, build it out. You should have a little easier time once you get over starting to work with Mongo. And I think you'll find that you're pleasantly surprised at how easy it can be. Okay? Once you're done that, come on back for the next lesson on Cosmos DB.